Define and discuss the F distribution. Solution. Let us consider a stochastically independent chi-square random variable x1 and x2 having r1 and r2 the degree of freedom respectively. The joint probability density function of phi x1 x2 of u and v is given by phi x1 x2 equals to curly bracket starts 1 upon factorial r1 upon 2 factorial r2 upon 2 2 raised to power r1 r2 upon 2 into x raised to power r1 upon x1 raised to power r1 upon 2 minus 1 and x2 raised to power r2 upon 2 minus 1 into e raised to power minus x1 x2 upon 2 and 0 elsewhere. 0 is less than x1 is less than infinity, 0 is less than x2 is less than infinity. Let us define a new random variable. F of x1 is equal to x1 upon r1. F is equal to x1 upon r1 upon x2 upon r2, and we are to find the probability density function of g1 t of f. The equations f is equal to x1 upon r1 upon x2 upon r2, z is equal to x2, defining a one-to-one transformation that maps the set a is equal to x1 x2 such that 0 is less than x1 is less than infinity and 0 is less than x2 is less than infinity onto the set b is f of z such that 0 is less than f is less than infinity and 0 is less than z is less than plus infinity. Since x1 is equal to r1 upon 2 z f of 1 x2 is equal to z, the absolute value of the Jacobians of the transformation is given by j is equal to r1 upon 2 into z, joint probability density function of f of z of the random variable f of f and z is equal to x2 is then g of f of z is equal to curly bracket starts 1 upon r factorial r1 upon 2 factorial r2 upon 2 into 2 raised to r1 r2 upon 2 bracket starts z r1 z f upon r2 bracket close raised to power r1 upon 2 into exponential square bracket starts in z upon 2 minus z upon 2 bracket starts r1 f upon r2 plus 1 bracket close square bracket close r1 upon r2 into z and 0 elsewhere, provided f of z belongs to be the marginal probability density function g1 t is equal to minus infinity to plus infinity g of f of z dz is equal to 0 to infinity r1 upon r2 raised to power r1 upon 2 f of r1 upon 2 minus 1 upon factorial r1 upon 2 into factorial r2 upon 2 into 2 raised to r1 plus r1 2 upon 2 into z raised to power r1 plus r1 2 upon 2 minus 1 exponential square bracket starts minus z upon 2 bracket starts r1 f upon r2 plus 1 bracket close square bracket close dz. Let us change the variable of integration by writing y is equal to z upon 2 bracket starts z1 f upon r2 plus 1 bracket close. Therefore we have g1 t is curly bracket starts r1 upon 2 raised to power r1 upon 2 f r1 upon 2 minus 1 upon factorial r1 upon 2 into factorial r2 upon 2 into 2 raised to power r1 plus r2 upon 2 bracket starts 2y upon r1 upon f upon r2 plus 1 bracket close raised to power r1 plus r2 upon 2 minus 1 e raised to power minus y bracket starts 2 raised to power y upon r1 f upon r2 plus 1 bracket close dy is equal to curly bracket starts r square bracket starts r1 plus r2 upon 2 bracket close square bracket close into r1 upon r2 bracket close raised to r1 upon 2 upon factorial r1 upon 2 into factorial r2 upon 2 into f raised to power r1 upon 2 minus 1 upon bracket starts 1 plus r1 f upon r1 bracket close r1 plus r1 raised to power r1 plus r2 upon 2 where 0 is less than f is less than infinity 0 elsewhere. Accordingly x1 and x2 are the stochastically independent the chi-square variable with r1 and r2 the degree of freedom respectively. Then f is equal to x1 upon r1 upon x2 upon r2. The immediately preceding probability density function is g1t. The distribution of the random variable is usually called as an f distribution.